Hey guys, here's just a video to show you why the segments are related the way they are. I believe I mentioned this in class, but we didn't have enough time to really go through it in detail. So let me just show you why you have to multiply those pieces the way you do. So let's just draw two chords. Let's start out with the basic two chord example. And just to make things easier, I'm just going to call this little a, little b, little c, and little d. And we already learned this rule, so if you watch the video or you have the notes from class, you know that a times b should equal c times d. But why? What we do here is we actually make a triangle out of these things. And I don't know if you remember, but when we did a whole bunch of triangle stuff way back when, sorry that one didn't come out so straight, but you can see it. When we did the triangles way back when, we had this sort of like bow tie looking thing a lot. And what we were able to do is we were able to show that these two triangles are in fact similar. You've got vertical angles here, and all we really need is one other pair of angles. And we couldn't really do this proof with circles until we learned more about circles. And earlier in the chapter we learned something about angles that are inscribed. Inscribed angles are half the measure of their intercepted arc. Okay? Well, this angle hits this arc, and so does this angle. Okay? When we did the bow tie problems way back when, we usually had parallel lines involved. These are definitely not parallel lines, but these two angles are in fact congruent because they hit the same arc. You could have made the same argument for those two angles. They hit the same arc. It doesn't really matter. As long as we can show two angles are congruent from one to the other, we've got similar triangles. If we have similar triangles, we know that their sides are proportional. We spent a month on similarity, and that was one of the relationships. They have congruent angles, the corresponding angles are congruent, and the sides are proportional. So you just got to figure out which side goes with what. So if these are the two angles that are congruent, that means basically if I, matched up side for side and angle for angle, this side would actually match up to this side, for a ratio point of view. So B would go with D, B would go with D as C goes with A. And I know what you're thinking. You're like, Mr. Miller, you told us A goes with B. Well, in the formula it does, because that's what happens after you multiply. The C goes with D after you multiply. Look at what I have here. This is just a proportion. I haven't multiplied yet. If I cross multiply, look what you get. AB equals CD. Oop, there's my cat. That's Starburst. When you cross multiply like we would every time we did a proportion, you'd see AB does in fact equal CD. So this piece times this piece equals that piece times that piece, which is exactly what we had in our formula. And that's what we did all along. Now, instead of having to draw the triangles every single time and set up a proportion and cross multiply, we just know this as a rule because of the similarity. Okay? Now again, don't feel the need to like recreate, reinvent the wheel, so to speak, when you do these problems. But I figured you might be curious as to why it is what it is. It does seem random at first, but if you just look at it from a triangular point of view, it does make sense. Okay, the other ones can be done in exactly the same way. It's just some of the triangle parts are outside the circle instead. I'm not going to do it all the way through, but you can probably envision it. If I would draw this triangle and that triangle, AED and BCE, you can do the same argument, and it would be, the product of the like this times this over this equals the total over the total, and you cross multiply, and it works itself out. Okay, all right. So that should help with the concept. Again, if you need help with any of the basics, be sure and let me know, and I will talk to you guys later.